Welcome to Summarize Science. We all know AI language models are getting incredibly smart, but they have a big secret. They often make up their reasoning as they go. Even when an AI gets the final answer right, its step-by-step logic can be flawed, which is a huge problem for important tasks where the why matters as much as the what. To solve this, researchers introduced a new system called VERICOT, which acts like a logic checker for an AI's brain. So, how does it work? Think of VERICOT as a universal translator and a strict fact-checker combined. As you can see in this diagram, it takes an AI's reasoning, written in plain English, and translates each and every step into the precise language of formal logic. It then checks if each logical statement is actually supported by the facts given in the source document, the question, or just plain old common sense. If a step doesn't logically follow, the system flags it as unverifiable. VERICOT is so precise that it can categorize the errors it finds. For example, it can flag a step as ungrounded if the AI just pulled an idea out of thin air. Or it can find a contradiction where the AI's reasoning clashes with facts it already established. This level of detail is crucial for understanding why an AI made a mistake. The researchers put VERICOT to the test across several challenging domains, including legal reasoning, biomedical questions, and logic puzzles. As these results in Table 1 show, VERICOT consistently outperformed other methods in identifying logically sound reasoning chains. It achieved a much higher pass rate while maintaining incredible precision, proving that reasoning verified by VERICOT is far more trustworthy. But VERICOT isn't just a referee, it's also a coach that helps the AI improve. One application is called inference time self-reflection. When VERICOT finds a mistake, it sends feedback to the AI, essentially saying that last step was illogical, try again. This chart beautifully illustrates the result. After self-reflection, the proportion of valid reasoning chains skyrockets, while errors like ungrounded steps and contradictions drop significantly. They also used VERICOT to create better training data. By collecting thousands of these verified, logically perfect reasoning examples, they were able to fine-tune an AI model. This is like giving a student a textbook filled only with gold standard, perfectly solved problems to learn from. The result was an AI that was naturally better at thinking logically from the get-go. So let's recap the key takeaways. AI reasoning is often unreliable, but VERICOT provides a powerful way to translate and validate it using formal logic. This verification signal is so effective that it can be used to help AIs correct their own mistakes and to train them to become fundamentally better reasoners. This work is a massive step towards building AIs we can actually trust for critical applications. Imagine a future where AI assistants in medicine or law don't just give you an answer, but can provide a provably correct logical path to back it up. Thanks for watching Summarize Science.